So one last thing before we leave this that I didn't point out. Here's the plot and it's tied into the data. But if we go back to these variables, one of the things that we can do is use this setup to evaluate what happens when we change the variables around. So let's put this plot over here. These variables are linked into the calculation. So if I wanted to see, well, here's the plot that I have for these variables, what happens if I reduce the hydraulic conductivity, or if I increase the hydraulic conductivity by 10, then I do this and just press that, and it automatically redoes all the calculations, and there's what the profile looks like. So the heads at the endpoints are still 0 and 20, but now we see we have this situation where the hydraulic head rises up above this linear connection between these 2 points just very slightly. And in fact, it looks like there would be no divide in this case. And by the same token, if I reduce K by 10 times from the original, instead of 40 meters of head between the two endpoints, I have 400. Okay, so we can experiment in that way. We can also try varying some other things. I had this recharge hooked up where this is 0.2 meters per year, then I did the conversion here, and this is written over here. So the calculations use whatever is in this cell, but one thing I could do is say, well, what happens if I increase the recharge from 0.2 to 0.25? Then I see that I go from, it was about 40 at the midpoint, or at the high point, and now I increase it to 60. Okay, so it's very easy to do experiments like that. I guess it goes from 50 up to 60. Very easy to do these experiments and try out the different values, and the nice thing is that you just change these numbers, and because it's done with variables, the calculations are automatically updated.